Opening speech to Madripoor venture capitalists. Good evening, distinguished disruptors of industry and patrons of innovation. Welcome to the epicenter of possibility of Velocitech Robotics. I'm Dr. Magnus von Griesbolt, the man whose childhood dream of building an army of robots to clean my room somehow snowballed into the revolutionary venture you're about to hear today. Spoiler alert, it's bigger than clean rooms. Now, don't let the doctor in my name intimidate you or think of me less as a mad scientist and more as a visionary with a penchant for lasers, many missiles, and world-changing technology. Slide 1, Welcome to Velocitech Robotics. Ladies and gentlemen, imagine a world where engineers collaborate seamlessly across borders, where talent is rewarded not with just paychecks but with the power to shape the future. That world is Velocitech Robotics. Our flagship product, the Crusader Cyclone, is not just a combat robot, it's a walking, blasting, missile-firing declaration that says, why settle for average when you can have the best? Slide 2, Vision Mission. At Velocitech, we don't just create technology, we create revolutions. Our vision is simple, to decentralize robotics innovation and empower engineers to create freely, boldly, and disruptively. Our mission? It's all about engineering freedom as giving the world open source platforms, elite tools, and cutting-edge products to redefine what's possible. Slide 3, the Crusader Cyclone. The Crusader Cyclone. Nicknamed the Giant Killer because, well, it literally eliminates giants competitors, that is. Imagine dual laser cannons, many missiles, and reinforced armor so advanced it would make a tank jealous. But let's not overlook its real superpower, being co-created by the brightest minds on our decentralized platform. This isn't just a product, it's a movement with missiles. Slide 4, Decentralized Engineering Platform. Our decentralized platform is like the Avengers, but for engineers. Here, the world's top talent collaborates in real time, using a proprietary token system to fuel innovation. These tokens? Not just monopoly money. They're currency for housing, transportation, and investing right here in Madripoor. It's a system so efficient it might even impress your accountant. Slide 5, Engineering as a Sport. At Velocitech, we recruit engineers like NFL teams draft quarterbacks. Signing bonuses, luxury housing, and world-class facilities are just the start. We turn tech talent into rock stars, and by rock stars, I mean individuals who can build machines capable of, protecting the planet or at least securing a few lucrative defense contracts. Slide 6, Key Skills for Success in Robotics, 2025 to 2026. Our engineers are the Swiss Army knives of the robotics world. They're fluent in Python, masters of machine learning, and absolute wizards in mechatronics. Together, they're crafting innovations so advanced, you'll wonder why you ever doubted the future of robots. Slide 7, Financials ask. Now, let's talk numbers. We're seeking $50 million to scale our platform, ramp up production, and keep our talent pipeline overflowing with brilliance. The payoff? A projected $500 million in revenue by 2027. With a 10.5% cash-on-cash return and a giant-slaying IRR of 11.2%, the Crusader Cyclone practically prints money and lasers. Slide 8, Why Velocitech Robotics? Why Velocitech? Because we're not just building robots, we're rewriting the playbook on innovation. With our disruptive model, global talent pool, and proven track record, investing in us is like betting on a winning team before the game even starts. Slide 9, Call to Action. So, what do you say, Madripoor? Let's engineer freedom, decentralize innovation, and dominate the market together. Invest in Velocitech Robotics. Not because you have to, but because you'd regret it if you didn't. Now, who's ready to join the revolution? Thank you. And remember, if you don't invest, the Crusader Cyclone might just come knocking a broken bar with missiles. Presentation title, Engineering Freedom, Open Source Robotics and the Crusader Cyclone Revolution. Slide 1, Welcome to Velocitech Robotics presented by Dr. Magnus von Griesbolt, Visionary CEO of Velocitech Robotics. Tagline, Empowering Engineers, Decentralizing Innovation. Slide 2, Vision Mission. Our vision Velocitech Robotics is more than a companion, it's a movement. We're decentralizing robotics engineering through open source innovation, redefining how engineers are recruited, trained, and rewarded. Our mission? To create the most advanced combat robotics systems, powered by a global, decentralized network of elite engineers and supported by cutting-edge tokenomics. Slide 3, the Crusader Cyclone. Nickname, the Giant Killer. Key features, LRC-10 dual laser cannons, GR-22 mini missiles, reinforced armor with 300% more firepower, applications, military, security, and expeditionary missions. Developed by the best, leveraging our decentralized engineering network. Slide 4, Decentralized Engineering Platform. Open source innovation. Engineers collaborate globally through our open source platform. Decentralized system ensures real-time updates, scalability, and transparency. Tokenomics for innovation. Our proprietary token system incentivizes contributions and ensures fairness. Tokens can be used for housing, food, transport, and even investments in Madripoor, our autonomous engineering hub. Slide 5. Engineering as a sport. Recruitment. Like the pros, engineers are treated like elite athletes, draft picks for the top talent. Signing bonuses up to $1 million. All expenses paid. Lifestyle, housing, food, transport, and more. World-class facilities. Training camp, robotics labs, simulators, and AI development hubs. Performance-based rewards, continuous incentives tied to innovations. Slide 6. Key skills for success in robotics, 2025 to 2026. Our engineers master programming languages, Python, C++, and ROS. Machine learning, AI, autonomous decision-making. Computer vision, advanced targeting and navigation. Mechatronics, seamless integration of hardware and software. Simulation modeling, rapid prototyping. Problem-solving. Collaboration, tackling challenges as a global team. Slide 7. Financials. Ask investment opportunity. Funding required, $50 million. Allocation, decentralized platform development, 35% Crusader Cyclone production, 30% global engineering talent acquisition, 25% marketing miscellaneous, 10% projected returns, $500 million in revenue by 2027, fueled by decentralized innovation and scalable robotics solutions. Slide 8. Why Velocitech Robotics? Disruptive model, decentralized, open source engineering. Elite talent pool, global network of the best roboticists. Scalable innovation, agile development backed by tokenomics. Proven product, the Crusader Cyclone leads in combat robotics. Slide 9. Call to action. Join the revolution. Your investment powers not just a company but a global movement. Together, we'll redefine robotics engineering and create the future of combat systems. Venture capital presentation, unlocking the future of robotech innovation in 2025. Slide 1. Introduction. Title, Unlocking the Future of Robotech Innovation, The Journey to Becoming a Self-Taught Veritech Cyclone Robotics Software Engineer. Opening statement. The next frontier in engineering lies within the convergence of robotics and artificial intelligence. By empowering individuals to become self-taught experts in robotech, we can push the boundaries of innovation in motorsports, particularly competitive racing technology like the Crusader Veritech Cyclone. Objective. Today, I present a roadmap for how self-taught robotics engineers will drive the future of the Crusader Veritech Cyclone, shaping the future of racing with cutting-edge AI and robotics technology. This initiative not only promises to advance high-performance engineering but also offers a prime opportunity for investment, particularly through open-source collaboration and decentralized tokenomics models. Slide 2, The Robotech Revolution. Title, Why Robotics AI Are the Future of Racing and Innovation. Impact on Racing. AI-driven robotics will redefine every aspect of motorsports. The Crusader Veritech Cyclone is a prime example, blending robotics and artificial intelligence to deliver real-time performance enhancements, autonomous control, and improved vehicle dynamics. This will offer unprecedented speed, precision, and driver safety. Investment opportunity. The rise of autonomous systems and AI in racing presents an explosive growth opportunity. Investing in this intersection of robotics and AI will unlock vast potential not only for racing but also for the broader automotive and technology industries. Slide 3, The Self-Taught Engineer Revolution. Title, Empowering Engineers to Become the Next Innovators in Robotech. Step 1, Learn the basics of robotics AI. The foundation of this journey lies in understanding the core principles of robotics and AI. By mastering the fundamentals of machine learning and robot design, engineers will contribute directly to the Crusader Veritech Cyclone, pushing the limits of racing technology. Step 2, Choose your tools. The success of a self-taught engineer is rooted in selecting the right tools. Tools like ROS, Robot Operating System, Python, C++, and libraries like OpenCV will enable engineers to build autonomous control systems for racing applications, including sensor-driven decision-making and real-time performance adjustments. Slide 4, A Practical Approach to Learning. Title, Hands-on Practice and Building Real-World Projects. Step 3, Engage in hands-on practice. Real-world application of these concepts is essential. Engineers will build robots, engage in coding challenges, and design simulation software for racing. This practical approach will focus on everything from AI-powered race strategy systems to robotic control of racing vehicles. Step 4, Join the robotics community. Networking is key. By participating in online forums, meetups, and hackathons, self-taught engineers can connect with other innovators, gain mentorship, and collaborate on key technical challenges, driving forward the Crusader Veritech Cyclone project. Slide 5, Building the Portfolio and Gaining Recognition. Title, How Self-Taught Engineers Can Stand Out. Step 5, Stay updated with trends and innovations. To stay competitive, engineers must keep up with the latest developments in AI and robotics. By following leading industry blogs, YouTube channels, and research papers, engineers can leverage new techniques and tools to enhance the Crusader Veritech Cyclone's autonomous capabilities. Step 6. Build a portfolio. A robust portfolio on platforms like GitHub is critical. Engineers will document their work on AI-driven race simulations, robotic navigation systems, and more, showcasing their skills and attracting attention from potential collaborators and investors. Slide 6. Mentorship and continuous learning. Title: The Power of Mentorship and Networking. Step 7. Seek mentorship and feedback. Mentorship is invaluable. Experienced engineers, especially those in the robotics and AI industries, will offer guidance to help self-taught engineers grow faster, refining their skills for complex projects like the Veritech Cyclone. Networking for success. A collaborative network of engineers, racers, and AI professionals will form a decentralized, open-source ecosystem for continuous innovation. Through hackathons, industry events, and global collaborations, engineers will push the boundaries of autonomous racing technology. Slide 7. Why invest in self-taught engineers? Title: The Value Proposition for Venture Capital. Scalable, high-impact workforce. Investing in self-taught engineers will create a scalable, decentralized workforce capable of quickly adapting to cutting-edge technological challenges. These engineers will be key contributors to the Crusader Veritech Cyclone project, driving not just technology but business growth through innovations in racing. Disruptive innovation. Self-taught engineers will drive disruptive innovation in AI and robotics, revolutionizing industries well beyond racing. With robotics in motorsports, we are poised for exponential market growth, while opening opportunities for tokenomics-based engagement, community-driven development, and decentralized innovation. Revolutionizing robotics with open source. The open-source approach will accelerate product development and bring in contributions from global experts, reducing costs while increasing the pace and quality of innovation. Our tokenomics model will reward contributors, aligning incentives for engineers to deliver high-performance, scalable solutions for the Veritech Cyclone. Slide 8. Conclusion. Call to action. Title: A self-taught robotics engineer, the future of racing innovation. Closing statement. Empowering the next generation of self-taught engineers will not only drive success in projects like the Crusader Veritech Cyclone but will position us at the forefront of a revolution in racing, robotics, and artificial intelligence. With your investment, we will leverage the power of open-source collaboration, decentralized engineering, and cutting-edge AI to shape the future. Call to action. Join us in revolutionizing the world of robotics and racing. Let's invest in the talent of tomorrow. Our engineers who will redefine the future of technology and create groundbreaking products like the Crusader Veritech Cyclone. This presentation focuses on how venture capital can fuel the development of self-taught engineers working with robotics technology, specifically in competitive racing. By emphasizing open-source collaboration, decentralized efforts, and tokenomics-driven models, this approach will generate continuous innovation and the market growth for the Crusader Veritech Cyclone project. The opportunity lies in supporting a global community of robotics engineers, racing experts, and innovators who are ready to take the industry to the next level. The Malone Lam XP, the ultimate experience for robotic engineering and adventure. As the CEO of Velocitech Robotics, I understand the allure of both innovation and adventure where technology, daring feats, and ingenuity collide. In the spirit of Dr. Magnus von Bolt's invention of the Malone Lam XP, a revolutionary concept that gives us an inside look at a thrilling story of technology, personal ambition, and strategic risk-taking, let's explore how this narrative unfolds in a first-person experience. A life of adventure with robotics, crypto, and exploration. Malone Lam XP, experience points. The core of this storyline is about using tech not just for wealth, but for adventure. Malone's life reflects the spirit of exploration, not merely in the physical world but also in the digital domain, where technology is no longer bound by traditional rules. Robotics, AI, and tokenomics. Malone's future. After this grand adventure, Malone could easily pivot into becoming a self-taught robotics engineer, leveraging his tech savvy and experience from the heist into developing next-gen systems like the Crusader Veritech Cyclone. Tokenomics for the future. Leveraging decentralized finance, Malone could embed tokenomics principles into every aspect of his life via driving his tech empire while enjoying decentralized, all-expenses-paid adventures in exotic locales like Madripoor, a location rich in both adventure and tech opportunities. Living the life of an adventurer, with a combination of cryptocurrency earnings, robotics, and self-taught expertise, Malone could shape a future that allows him to live freely, adventuring through the high-tech world he helped build free from the constraints of the past, on his terms, and with cutting-edge technology leading the way. This thrilling narrative, built on the spine of tech, robotics, and high-stakes digital adventures, highlights how Malone Lam's endgame transcends mere wealth. It's about redefining how technology is integrated into personal freedom, self-taught expertise, and the future of humanity's interaction with robotics and AI. As a Velocitech robotics engineer, I see how the spirit of adventure, innovation, and the pursuit of freedom can truly be realized through the Malone Lam XP, a concept that seamlessly blends open-source technology, tokenomics, and cutting-edge robotics without the dark undertones of a neo-noir storyline. Let me explain how Velocitech Robotics enables you to live the Malone Lam XP, using these principles to craft a future of exploration and innovation. Living the Malone Lam XP with Velocitech Robotics. 1. Open-source technology, empowering innovation and adventure. The power of open-source robotics. At Velocitech Robotics, we believe that open source is the foundation of true technological freedom. By sharing code, designs, and ideas, we enable engineers like yourself to tinker, innovate, and create with no boundaries. This spirit of collaboration means that, just like a Malone Lam, you can take existing technologies and adapt, improve, and personalize them to fit your needs. Malone Lam XP's blueprint. Imagine the Malone Lam XP is a personalized robotic system that allows you to interact with and navigate the digital and physical world with freedom. Using open-source platforms like ROS, Robot Operating System, we can equip Malone Lam XP with autonomous navigation, computer vision, and AI-driven decision-making, all built from shared, open-source software and hardware. Living in the world of robotics, open source lets you step away from traditional corporate constraints. As a Velocitech engineer, you are free to experiment, build next-gen robotics systems, and even adapt the Malone Lam XP to different environments, whether you're navigating urban spaces, handling complex industrial tasks, or pursuing adventure in the metaverse. 2. Tokenomics, digital currency as a key to a free lifestyle. Tokenomics in robotics. The future of robotics and artificial intelligence is intertwined with decentralized finance and tokenomics. By integrating blockchain technology into robotics, Velocitech Robotics empowers engineers to create systems where users can earn tokens through robotic interactions and data contributions. Think of Malone Lam's XP as a digital person. As you use and develop it, you earn tokens that could have real-world value or be used to unlock premium robotic upgrades. Revolutionizing ownership. Instead of owning physical assets, you could own digital assets, like smart contracts, tokens, and NFTs that represent your robotic creations. By integrating smart contracts and tokenomics into Velocitech Robotics systems, engineers like you can build autonomous robots that work for you and generate income through data collection, tasks performed, or by interacting with others in decentralized ecosystems. Malone Lam XP in action. Imagine living the life of an adventurer while your robotic systems are earning tokens for you. As you explore new environments, whether physical or digital, your robots assist in gathering data, performing tasks, and earning tokens in the process. You can then reinvest those tokens into upgrading your systems, exploring new worlds, or even collaborating with other engineers to create new technologies. 3. Living the Malone Lam XP, a life of adventure and innovation. Freedom to explore. With open-source technologies and the decentralized economy of tokenomics, you are no longer restricted by the traditional models of income, work, or even ownership. The Malone Lam XP represents a new kind of freedom where the adventurer in you can leverage the latest tech to experience life on your terms. Continuous innovation. At Velocitech, we are constantly evolving our systems and platforms to push the boundaries of what is possible. Using open-source robotics, you can build your personal Malone Lam XP, constantly upgrading and evolving it based on the latest tech developments in robotics, AI, and blockchain. With every step forward, you're not only improving your life but also contributing to the larger community. Exploring new realms. The combination of open-source systems and tokenomics allows for a truly unique lifestyle. Whether you're creating autonomous delivery robots, exploring virtual worlds, or helping to solve real-world problems, the Malone Lam XP allows you to continuously engage in new adventures physically, digitally, and financially. 4. The Velocitech ecosystem, a new way to live, work, and play. Seamless integration. The Velocitech Robotics ecosystem supports the development of open-source robotic systems, where engineers, adventurers, and creators alike can come together. Using tools like AI-driven decision-making, machine learning, and cloud computing, you can build and control robotic systems that are constantly evolving, improving, and generating value. This isn't just a tool, it's a way of life. Community of engineers and innovators. At Velocitech, we foster a global community of roboticists, engineers, and adventurers who are united by the same goal, to create and live in a world where technology is used to empower individuals. Just like a Malone Lam, who pursued freedom through cutting-edge technology, you can now be a part of a collective that is constantly innovating and improving the tools at your disposal. Living the dream. The future isn't just about cryptocurrency or robotic systems, it's about living a holistic adventure where every decision is driven by personal curiosity, freedom, and the endless potential of open-source technologies. The Malone Lam XP allows you to design your life around exploration, innovation, and financial independency are fueled by technology that works for you. Conclusion: the future is open source and tokenized. In the world of Velocitech Robotics, we embrace the Malone Lam XP not as a mere narrative, but as a blueprint for a life defined by innovation, exploration, and the freedom to shape your own future. Through open source systems and tokenomics, we provide the tools to break free from traditional paradigms and embark on adventures that are only possible in a world where technology knows no bounds. As a Velocitech engineer, you are not just building the future, you're living it. Are free, adventurous, and limitless. Velocitech Robotics, engineering freedom, empowering innovation. Slide 4, Decentralized Engineering Platform. Open source innovation, global collaboration. Our platform connects engineers worldwide, enabling them to co-develop cutting-edge robotics. With an emphasis on open source principles, every design, algorithm, and update is accessible to the community, ensuring a continuous flow of innovation. Real-time development. Utilizing a decentralized architecture, updates and contributions are implemented in real time. Engineers can seamlessly integrate changes, test new modules, and collaborate without the delays of centralized systems. Scalability, transparency. Projects scale effortlessly as the community grows, allowing rapid expansion. Transparent contribution tracking ensures engineers receive credit and rewards proportionate to their input. Tokenomics for innovation, incentive-driven system. Our proprietary token, Cyclone Coin, rewards engineers based on contributions, such as code commits, design submissions, and problem-solving achievements. Tokens are distributed fairly through a merit-based system. Real-world utility. Cyclone Coin isn't just a reward, it's a resource. Living expenses, covers housing, utilities, and meals in Madripoor, our cutting-edge engineering hub. Transportation, provides personal and professional travel support. Professional growth, invest in advanced training programs or industry certifications. Equity options, tokens can also be used to purchase equity stakes in Velocitech Robotics projects. Madripoor, autonomous engineering hub. Located in a tax-friendly, innovation-driven territory, Madripoor is a self-sustaining ecosystem for roboticists. Facilities include advanced RD labs, residential areas, and leisure zones to ensure holistic well-being and peak productivity. Slide 5, Engineering as a sport. Recruitment like the pros draft picks for the elite. Annually, Velocitech Robotics conducts global drafts to select the top 1% of engineers. Engineers are scouted based on performance in competitions, contributions to open source projects, and innovative achievements in their fields. $1 million signing bonuses. Top recruits receive competitive signing bonuses of up to $1 million. Additional incentives include long-term contracts with performance escalators. All expenses paid lifestyle. Engineers live worry-free with company-provided housing, world-class dining, and comprehensive healthcare. Transportation support includes private commutes and business-class travel for international collaborations. World-class facilities training camp for engineers. Equipped with state-of-the-art robotics labs, featuring cutting-edge simulation tools, AI testing environments, and prototyping workshops. Access to a global mentorship network, pairing recruits with the brightest minds in robotics. Performance-based rewards. Engineers earn bonuses and promotions based on tangible contributions, such as successful project launches, patent filings, and innovative breakthroughs. Gamified performance metrics keep engineers motivated and recognized. Would you like to expand further on Cyclone Coin's economic model, or should I include visuals like workflow charts or token use cases? Slide 6, Revolutionizing Agile Project Management for Robotics. Open Source, Decentralized Agile Framework. Core Principles. Our decentralized Agile project management system merges open source collaboration with distributed governance to streamline robotics development. Engineers and contributors operate within a flexible, scalable, and highly efficient workflow, ensuring global accessibility and participation. Real-time task allocation and tracking. Tasks are dynamically assigned based on individual expertise, workload balance, and project priorities. Blockchain-backed smart contracts enforce task deadlines and automatically reward contributors upon completion. Sprint planning on a global scale. Cross-time zone sprint cycles enable round-the-clock development, with contributors passing work seamlessly across geographies. All contributors access a live project dashboard that syncs in real time, allowing transparent progress tracking and adaptive resource allocation. Integrated skill development through collaboration. Our Agile framework ensures engineers gain mastery over essential robotics skills while working on cutting-edge projects. Programming mastery. Python and C++, essential for core robotics programming. ROS, Robot Operating System, standardized for distributed control and communication in robotic systems. Open source code libraries provide a foundation for efficient problem solving. Machine learning AI. Integrated with agile workflows, machine learning modules are built collaboratively, enabling autonomous decision-making for robotic systems. Peer-reviewed algorithms ensure reliability and adaptability. Computer vision. Advanced AI models for targeting, object detection, and navigation are collaboratively developed and trained on shared datasets. Contributors use real-world scenarios simulated in our decentralized system to refine accuracy and responsiveness. Mechatronics. Hardware-software integration is approached collaboratively, ensuring seamless communication between mechanical components and software controls. Modular design principles allow iterative improvements without disrupting overall system functionality. Simulation modeling. Our platform features a cloud-based simulation environment where prototypes are tested in virtual spaces before physical implementation. Engineers share and refine models in real time, accelerating the iterative design process. Global problem-solving collaboration. Engineers tackle challenges through collective brainstorming sessions and global knowledge-sharing hubs. Contributions are recognized and rewarded through Cyclone Coin, incentivizing active participation in problem-solving and fostering a competitive yet cooperative spirit. Agile decentralization benefits transparency and trust. Each task, decision, and deliverable is recorded on an immutable blockchain ledger. Stakeholders and contributors can audit the development process at any stage. Decentralized governance. Engineers and contributors vote on key project milestones and system upgrades. Token-weighted voting ensures fairness and aligns incentives with project goals. Enhanced scalability. Decentralized nodes ensure that as the engineering workforce grows, the system adapts to manage the increased complexity without bottlenecks. Empowering engineers to lead. In 2025 to 2026, our engineers aren't just technical experts, they're visionaries empowered to innovate autonomously within a structured, decentralized system. Collaborate globally, transcending geographic barriers. Elevate their skills through hands-on contributions to groundbreaking robotics projects. Would you like further elaboration on the technical tools used within this agile system or examples of successful decentralized projects? Technical tools in our decentralized agile system. To maximize the potential of our open-source, decentralized agile project management system, we leverage cutting-edge tools that empower engineers to collaborate seamlessly, innovate rapidly, and track progress efficiently. These tools ensure that all stages of the project lifecycle, design, simulation, prototyping, and deployment, are supported by high-performance software and hardware systems. 1. Decentralized task management with blockchain-backed smart contracts blockchain platform, for example, Ethereum, Polkadot. Our decentralized system runs on a blockchain to guarantee that every transaction, update, and task is recorded immutably. Using smart contracts, we automatically trigger task assignments, approvals, and rewards based on predefined conditions, for example, task completion, milestones achieved. Key benefit, transparency and trust, where every contributor can track their contributions and rewards in real time. Example, an engineer completes a task to integrate machine vision into a Cyclone Unit's targeting system. The smart contract verifies the task's completion, automatically releasing their Cyclone coin as a reward. 2. Real-time collaboration tools. Slack, Microsoft Teams with ROS integration. Our collaboration tools integrate directly with Robot Operating System, ROS, providing engineers with live communication channels that are synchronized with a project management dashboard. Key benefit, real-time updates and direct access to system information, enabling seamless collaboration on tasks like debugging software or reviewing sensor integrations. Example, an engineer in North America identifies a software bug in the visual recognition system. They immediately alert the team through integrated channels, with the issue flagged in the project management system. Other team members from Europe and Asia pick up the task to resolve it. 3. Cloud-based simulation and the modeling gazebo simulator, VREP, Unity 3D. These simulation environments provide a virtual platform for engineers to test robotic systems, including the Crusader Cyclone's mobility, targeting system, and AI decision-making algorithms. Key benefit, engineers can simulate complex scenarios, for example, combat or obstacle navigation, before implementing physical prototypes, dramatically reducing trial and error cycles. Example, a team models a new navigation system for the Crusader Cyclone in Gazebo, testing how it will handle off-road terrain. The simulation is shared globally, allowing engineers from different time zones to collaborate asynchronously. 4. Agile sprint management and tracking. Jira, Trello with blockchain integration. Our decentralized agile platform leverages Jira for sprint management and Trello for visual task tracking, all integrated into the blockchain to ensure data integrity and provide clear progress reports. Key benefit, a centralized dashboard offers full visibility into task progress, current sprints, and resource allocation, while decentralized governance ensures a transparent decision-making process. Example, a sprint to upgrade the Crusader Cyclone's AI algorithms is tracked using Jira. Each subtask, for example, data collection, algorithm improvement, integration testing, is logged and linked to the appropriate engineers, with progress verified via smart contract. 5. Continuous integration, continuous deployment, CI/CD, pipelines GitHub Actions, Jenkins. We use CI/CD pipelines to ensure that new software contributions are automatically tested and deployed into the system. This is particularly crucial for ensuring that updates to the Cyclone's targeting algorithms or AI decision-making components don't disrupt the overall system. Key benefit: faster development cycles with fewer bugs and more reliable deployments. Example: a new machine learning model is pushed to GitHub. Using Jenkins, the model is tested, integrated, and deployed to the simulation environment where it is immediately available for team review. 6. Global voting and governance with tokenomics DAO, decentralized autonomous organization. The governance of our robotics development is handled through a DAO, where engineers and stakeholders can vote on major decisions such as the allocation of resources or selecting project milestones. The DAO operates on Cyclone Coin, our proprietary cryptocurrency, ensuring alignment between contributions and governance decisions. Key benefit: every engineer has a voice in the direction of the project, ensuring that decisions are democratic and incentivized by token rewards. Example: after a successful prototype test, engineers vote on whether to move forward with the production phase using their Cyclone coins. This system ensures that only the most impactful ideas are pushed forward. 7. Performance metrics and reward system KPI dashboards, for example, Tableau, powered by. Performance metrics are tracked in real time using customizable dashboards, allowing project managers and engineers to visualize KPIs like task completion rate, time to market, code quality, and innovation speed. These metrics directly influence the rewards and bonuses engineers receive, creating a meritocratic environment. Key benefit: transparency and motivation, as engineers can see how their contributions impact the overall project success. Example: a dashboard displays that an engineer's machine learning model has reduced decision-making time for the Crusader Cyclone's targeting system by 30%. As a result, they receive a bonus in Cyclone coins and an invitation to the next strategy meeting. Summary: how our decentralized system supports robotics success. Agile and open source framework, collaboration is fostered globally with real-time updates, task management, and transparent rewards. Smart contracts, blockchain technology guarantees fairness and transparency, ensuring engineers are rewarded based on their contributions. Global collaboration, tools like Slack, GitHub, and simulation software allow seamless collaboration and problem solving. Skills and growth, engineers continuously evolve, mastering essential skills such as programming, AI, mechatronics, and system integration while contributing to groundbreaking projects. By building this decentralized agile system, we are not only revolutionizing the way robotics are developed, but also creating a sustainable ecosystem where innovation thrives through global collaboration and cutting-edge technology. Would you like further details on how each of these systems supports specific robotics innovations like the Crusader Cyclone? How our decentralized agile system supports robotics innovations like the Crusader Cyclone. Our decentralized agile system is specifically designed to foster innovation and collaboration at a global scale, and it plays a pivotal role in advancing complex robotics projects like the Crusader Cyclone. Here's how the system directly impacts key aspects of the Crusader Cyclone's development. 1. Real-time collaboration and seamless communication. Global teams working together. The Crusader Cyclone project requires continuous collaboration among engineers from diverse backgrounds, ranging from AI specialists to mechatronics experts. Our decentralized system, integrated with Slack and Microsoft Teams, allows for real-time communication. Engineers around the world can provide immediate feedback on design iterations, share insights on mechanical troubleshooting, and suggest algorithm optimizations for targeting systems. Example: an engineer in Japan develops a new sensor fusion algorithm that improves the Cyclone's targeting system accuracy. This engineer can instantly share their results via Slack, enabling the North American software team to integrate the algorithm with a ROS-based system running in our simulation environment. 2. Simulation and the modeling for prototyping. Accelerating prototyping cycles. Using cloud-based simulation tools like Gazebo and Unity 3D, our engineers can rapidly test changes to the Crusader Cyclone's behavior in virtual environments before implementing them in the real world. This minimizes risks and reduces the number of physical prototypes needed, allowing for faster iteration. Example: before launching the Cyclone into testing scenarios, the AI targeting system is simulated in Unity 3D. Engineers model how the Cyclone reacts to high-speed targets in a battlefield environment. Based on feedback from the simulation, the software is iterated to improve decision-making algorithms, reducing response time by 15%. 3. Blockchain-backed smart contracts for task management. Ensuring accountability and fairness. Using blockchain-powered smart contracts, we ensure that each engineer's contributions to the Crusader Cyclone project are fairly rewarded. As each task or milestone is completed, The smart contract automatically triggers a release of Cyclone coins, our proprietary tokens, creating a system that aligns effort with reward and provides transparency. Example, an engineer working on the GR-22 mini-missile integration completes a key task ensuring compatibility with the Cyclone's targeting system. The smart contract verifies the completion and automatically issues a bonus based on the pre-agreed conditions, tracked transparently on the blockchain. 4. Decentralized voting for decision-making and resource allocation. Democratic governance. Our DAO, Decentralized Autonomous Organization, allows engineers and stakeholders to vote on key decisions for the Crusader Cyclone's development. Whether it's selecting the next phase of the development cycle, approving resource allocation for advanced AI integration, or determining the next test location, the decision-making process is transparent and driven by those with a stake in the project. Example, after a successful test of the Crusader Cyclone's targeting system, the team votes on whether to proceed with adding more armor or improving the missile's targeting range. Engineers, who are actively working on those specific subsystems, cast their votes, ensuring that the most effective approach is chosen based on real-time results and contributions. 5. Agile sprint management and global coordination. Efficient sprint management. The Crusader Cyclone project requires precision in task management, especially when coordinating across multiple disciplines like AI, mechatronics, and weapons systems. Tools like Jira and Trello, integrated into our decentralized system, allow the team to break down complex tasks into manageable sprints, with clear priorities, timelines, and accountability. Example, the current sprint is focused on integrating dual beam cannons with the Cyclone's software system. The sprint involves multiple tasks such as hardware integration, software calibration, and safety checks. Each task is tracked in Jira, and engineers across different countries collaborate asynchronously, with the sprint's progress updated in real time. 6. Continuous integration, continuous deployment, CI/CD, for fast innovation, rapid development and deployment. The CI/CD pipeline ensures that software updates for the Crusader Cyclone's systems, whether it's targeting software, AI decision-making, or sensor fusion, are tested, integrated, and deployed quickly. This is crucial for keeping up with evolving battle scenarios and ensuring that the Cyclone's systems are always at peak performance. Example, as part of a new sprint, an AI algorithm update for decision-making is pushed to GitHub. The Jenkins server automatically tests the update, integrates it into the project, and deploys it into the simulation environment, all while ensuring that no code breaks existing functionalities. 7. Performance metrics and continuous feedback. Measuring innovation and contribution. Performance metrics tracked via KPI dashboards like Tableau allow the team to measure the success of each part of the Crusader Cyclone project. Engineers are continuously rewarded based on their contributions to key performance indicators such as system uptime, software responsiveness, and missile targeting accuracy. Example, the AI decision-making algorithm improves by 20% based on feedback from the KPI dashboard. Engineers responsible for the upgrade receive a performance bonus and recognition within the DAO, motivating them to continue optimizing the system. Conclusion, accelerating the Crusader Cyclone's development. Our open-source, decentralized system fosters rapid, transparent, and efficient development of robotics like the Crusader Cyclone. By using cutting-edge tools like blockchain, simulation environments, CI/CD pipelines, and agile project management, we empower a global team of engineers to innovate at an unprecedented pace. Each engineer, no matter their location, is incentivized and supported to push the boundaries of robotics, while the seamless integration of hardware and software ensures that the Crusader Cyclone remains at the forefront of technological advancements. This system not only accelerates the development of the Crusader Cyclone but also sets the stage for the next generation of autonomous robotic systems, reinventing the future of warfare, engineering, and innovation. Would you like to delve deeper into any specific aspect of the development process for the Crusader Cyclone, or how our decentralized system can be scaled further? Scaling the decentralized system for global innovation in robotics. Our decentralized system is built to foster global collaboration and innovation, and its scalability is crucial for advancing complex projects like the Crusader Cyclone. By leveraging cutting-edge technologies, streamlined processes, and flexible infrastructures, we can expand our system to handle more ambitious robotics projects in the future. Below are key strategies and features to scale the decentralized system further. 1. Expanding the open-source community. Global talent pool expansion. Our open-source platform thrives on contributions from a diverse, global network of engineers. To scale, we will expand the Madripoor engineering hub, allowing for more localized communities in strategic regions such as Asia, Europe, and South America. This will create an even broader talent pool, making it easier to attract top engineers from around the world who are eager to work on robotics projects like the Crusader Cyclone. Localized innovation. In each regional hub, We will prioritize localized challenges and innovations, such as developing AI for autonomous vehicles in urban environments or improving mechatronics systems for extreme battle conditions. These innovations will then be shared across the platform, allowing the global team to build upon each other's work. 2. Multi-layered blockchain for security and transparency scalability via Layer 2 solutions. The existing blockchain architecture can scale further using Layer 2 solutions like Polygon or Optimism, which offer faster and more cost-efficient transactions. This ensures that as our engineering teams grow, the platform can handle increasing volumes of smart contract executions, secure data sharing, and transaction processing without compromising performance. Tokenized contributions. As more engineers contribute, the blockchain can also facilitate the creation of additional tokens to reward specialized contributions. For example, we could introduce specialized Cyclone tokens that recognize work done specifically on missile systems, AI decision-making, or mechatronics components. This would create an even more detailed and sophisticated reward system, ensuring fairness across all stages of development. 3. Cloud-native infrastructure for seamless scalability distributed cloud services. Our current cloud infrastructure can be scaled vertically and horizontally by deploying more robust services through providers like AWS, Google Cloud, or Microsoft Azure. These cloud platforms provide the necessary computational power to handle the complex simulations and AI models needed for the Crusader Cyclone's development. Edge computing for real-time processing. As robotics technology becomes more advanced, we need faster processing times. By integrating edge computing with our cloud systems, we can ensure that computations needed for real-time decision-making, for example, missile guidance or AI targeting, happen on local nodes within the system, reducing latency and improving performance. 4. Advanced AI for automation and self-improvement self-optimizing systems. We can integrate machine learning operations, MLOps, into our decentralized system to create self-optimizing processes. For example, AI could analyze performance data from the Crusader Cyclone's missions to identify inefficiencies in targeting or system response, and autonomously adjust algorithms in real time to improve performance. As more robots and systems are developed and deployed, this AI system will become more efficient and accurate, continuously improving the system without direct human intervention. Federated learning. Federated learning enables decentralized machine learning where data remains on local devices, allowing AI models to be trained on each node, or robot, and then aggregated into a global model. This will ensure that our robots, like the Crusader Cyclone, continuously improve based on experiences from different environments without compromising security or privacy. 5. Scalable agility with modular development teams. Dynamic team expansion. As the need for more resources grows, we can dynamically scale our development teams by breaking down complex projects, like Crusader Cyclone, into smaller, modular tasks. Each modular unit is treated like its own self-contained project, complete with a dedicated agile team focused on specific aspects such as missile systems, AI integration, or armor technology. Automated task allocation. Using AI-driven task allocation, we can assign tasks to the most qualified engineers in real time. The system will prioritize tasks based on skill sets, availability, and performance metrics, ensuring that each piece of the project is handled by the best talent at the right time. This ensures that, even as teams grow exponentially, the quality of work remains high. 6. International tokenomics and resource allocation. Global resource management. With the growth of global engineering hubs, it's important to manage resources across various geographies. Our decentralized system uses smart contracts to manage resources like housing, food, transportation, and toolkits. For instance, an engineer in Brazil could use tokens to book time in the Madripoor Robotics Lab, while an engineer in Germany could claim tokens to purchase high-end hardware needed for AI experiments. Decentralized finance, DeFi for investment. To further scale, we can implement a DeFi ecosystem within our platform. This allows engineers, investors, and stakeholders to pool resources into the Madripoor Autonomous Engineering Hub, earning interest on their investments and participating in the growth of future projects like the Crusader Cyclone. This tokenized investment system also makes it easier to fund new ventures, without relying on traditional funding models. 7. Cross-industry collaborations and open innovation. Cross-industry research. As we scale, we'll look to expand the scope of our open-source platform by forming partnerships with military organizations, defense contractors, and tech startups. These collaborations could bring in external expertise on specific systems, while simultaneously opening up new funding channels and the markets for the Crusader Cyclone. Open innovation challenges. By hosting open innovation challenges on the platform, we can draw in thousands of engineers, scientists, and designers who are passionate about robotics. The challenges will be focused on solving specific problems for the Crusader Cyclone, such as improving sensor accuracy, creating lighter materials for armor, or enhancing the missile's guidance system. Conclusion: preparing for the next frontier of robotics innovation to scale our decentralized system for the future, we leverage cutting-edge technologies, AI-driven automation, dynamic resource allocation, and global talent networks. This will allow us to efficiently develop world-class robotics projects like the Crusader Cyclone, ensuring we remain at the forefront of innovation. Through continuous improvement, transparency, and decentralized governance, we can create a self-sustaining ecosystem that rapidly adapts to the evolving landscape of robotics, unlocking limitless possibilities for the future. Would you like to explore how this scalable system will impact specific projects or how we can adapt this model to other sectors? Velocitech Engineering League, Application of Robotic Software Engineering Pathway 1. Introduction: Self-taught programmers. Approximately 1/3 of all programmers are self-taught, demonstrating that becoming a robotic software engineer is accessible, even without formal education. Pathway to Robotic Software Engineering. This pathway is designed for individuals with engineering backgrounds who are motivated to pursue robotics, whether for career advancement or personal passion, without the constraints of traditional academic programs. Practical steps for entry. The video outlines 19 actionable steps to becoming a robotic software engineer, focusing on practical resources such as YouTube tutorials, online courses, and curated learning materials. 2. Prerequisites. Target audience: engineers, mechanical, electrical, software, aiming to transition into robotics or software engineering. Students pursuing undergraduate or master's degrees, or working professionals unable to pursue a higher degree due to financial, societal, or geographical limitations. Key focus areas: addressing the gap for individuals unable to pursue a master's in robotics but still want to explore the field through accessible learning resources. Emphasizing the importance of self-motivation, a clear career focus, and resourcefulness in making up for gaps in formal education or resources. 3. Steps to become a robotic software engineer. Define your core motivation. Establish clear reasons for pursuing robotics, whether it's passion, career growth, or financial stability. Focus on personal motivation rather than trendy pursuits to prevent burnout and remain consistent in learning. Build a strong mathematics foundation. Essential mathematical concepts include calculus, linear algebra, probability, and differential equations. Leverage online resources like the Rob 501 Mathematics for Robotics YouTube playlist to strengthen the mathematical foundation necessary for understanding and developing robotic systems. Switch to Ubuntu. Transition from Windows to Ubuntu for a seamless experience in programming, especially when working with ROS, Robot Operating System, a key framework in robotics development. Complete a Linux crash course to master basic command line operations, which are crucial in robotics programming environments. Install Visual Studio Code. VS Code is the recommended guide for programming in robotics and will significantly enhance coding efficiency, debugging, and task management. Learn how to integrate different libraries and tools into VS Code to streamline robotic software development. Application to Velocitech Engineering League. The Velocitech Engineering League supports aspiring robotic software engineers by providing access to the same curated resources mentioned above. We enable self-motivated engineers to pursue their robotics careers using a practical, hands-on approach that mirrors the career path of Malone Lamb in the Malone Lamb XP framework. Self-taught programmers in the league are encouraged to start with math resources and hands-on coding projects, directly applying what they learned to robotics systems within Velocitech's open-source projects. Ubuntu and ROS integration will be a staple in league coding challenges and projects. Our mentorship programs will guide engineers through transitioning to Linux environments and utilizing ROS in real-world robotic applications. By leveraging Visual Studio Code, Velocitech engineers can engage in collaborative coding projects, optimizing the development process while enhancing their coding capabilities in robotics. As part of the Velocitech Engineering League, you are empowered to craft your robotic future through open-source resources, engineering knowledge, and collaborative innovation. This pathway opens doors to explore the exciting world of robotics without the need for a traditional academic or financial pathway. Velocitech Engineering League, Application of Robotics Software Engineering Pathway, Steps 4 to 6. 4. Initial setup. Install Ubuntu. As a member of the Velocitech Engineering League, the first step for all engineers is transitioning from other operating systems to Ubuntu. This is essential for utilizing ROS, Robot Operating System, and other tools commonly used in robotics development. Ubuntu is widely supported in the robotics field, ensuring compatibility with key software libraries and development environments. Define your purpose for learning robotics. Establish a clear why for pursuing robotics to maintain motivation and focus. Whether you're passionate about building autonomous systems, exploring AI applications, or working on human-robot interaction, Velocitech helps engineers connect personal curiosity with career growth. Install Visual Studio Code, VS Code. VS Code is the recommended guide for programming in the Velocitech Engineering League. It is crucial for writing, debugging, and managing robotics software projects efficiently. Velocitech provides a collection of customized extensions and tools to enhance the development experience, such as ROS extension packs and Python, C++, and TensorFlow integrations. Set up a Git environment. Learn the fundamentals of version control by setting up a Git environment. Git is indispensable in collaborative development, and the Velocitech Engineering League encourages using Git for managing projects, contributing to open source code bases, and tracking project versions. Keep a Git cheat sheet handy for quick reference to common commands and workflows. Prepare a Conda environment. Set up a Conda environment to easily manage and maintain software dependencies, especially for machine learning and robotic simulation tools. Velocitech emphasizes using Conda for organizing Python packages and ensuring consistency across projects in the league. 5. Programming Basics. Learn Python. Python is the ideal starting language for newcomers, widely used in machine learning, computer vision, and robotics development. It is easy to learn and has a supportive community. At Velocitech, Python is used in various robotics applications, including simulation, control systems, and AI-based perception. Resources like FreeCodeCamp tutorials and the Rob 501 Mathematics for Robotics playlist are available to accelerate learning. Learn C++. C++ is essential for low-level control, system integration, and efficient hardware communication. It is particularly crucial for performance optimization in robotic applications. After mastering Python basics, the League offers resources like University of Bonn's Modern C++ tutorials, which cover both general programming concepts and specialized robotics topics. 6. Advanced Programming Tools. Learn TensorFlow. For robotics applications involving machine learning, TensorFlow is the go-to tool. It is critical for building intelligent robots capable of perception, decision-making, and navigation. Velocitech Engineering League engineers are encouraged to dive into TensorFlow 2.0 and take courses from FreeCodeCamp or DeepLearning.ai on platforms like Coursera, specifically geared toward robotics-related machine learning tasks. Learn OpenCV. OpenCV is a cornerstone tool for computer vision tasks in robotics. Mastering it will allow Velocitech engineers to work on visual processing, object recognition, and pathfinding systems for robots. Velocitech offers both Python and C++ OpenCV tutorials through platforms like FreeCodeCamp and Workshop. Members also have access to OpenCV crash course playlists with a storyline approach, integrating visual tasks in real-world projects. Robotic simulation and tools. Learn Gazebo. Gazebo is an essential simulation environment used in conjunction with ROS to build and test robotic systems in virtual environments. Velocitech provides hands-on projects and tutorials for using Gazebo to simulate robot movements, sensor data, and real-time decision-making, providing engineers with practical skills before deploying physical robots. Learn ROS/ROS2. Begin learning ROS2 for future-proof compatibility with modern robotics standards. ROS2 enables efficient communication between robotic components, device control, and sensor data management. Velocitech members are given access to step-by-step guides and ROS2 tutorials, such as ROS2 Humble Hawksbill, to learn its practical applications in robotics software development. Project work. Define your own projects. The League emphasizes personal project development, allowing engineers to pursue projects aligned with their individual curiosity and career goals. Whether it's building a simple robot, developing an autonomous navigation system, or integrating AI, Velocitech encourages project-based learning. Velocitech offers tools like ROS2, OpenCV, and TensorFlow to help engineers develop their ideas into functional robotic systems. Explore projects in different domains. Exposure to diverse robotics fields such as perception, learning, planning, and controller is vital for holistic development. Velocitech provides insights into different robotics subfields and encourages engineers to try projects in areas like robotic vision, navigation, or AI-based learning systems. Velocitech Engineering League, Application of Robotics Software Engineering Pathway, Steps 7 to 9. 7. Find project lists. Available resources. Project lists for aspiring robotics engineers are made available on platforms like the LearnRoboticsandI.com website and the Velocitech Engineering League's YouTube channel. These resources are continuously updated and shared on LinkedIn to ensure all engineers stay current with the latest project ideas and opportunities. Types of project lists. Top 10 Machine Learning Projects for Beginners, focus on simple algorithms and practical applications for machine learning within robotics. Top 10 Computer Vision Projects for Beginners, hands-on projects focusing on object detection, image processing, and robotic vision tasks. Top 10 ROS Projects for Beginners, ROS-based projects aimed at teaching engineers how to control robots and implement various robotic tasks. Top 10 Robot Navigation Projects for Beginners, projects that explore navigation algorithms, including localization, mapping, and path planning. Top 10 Robot Perception Projects for Beginners, projects that develop sensory systems to detect the robot's surroundings. Top 10 Control Projects for Beginners, control theory projects that help engineers understand how to manage robot motion and actions. Future plans for projects. GitHub repositories. Each project will come with links to resources and GitHub repositories for easy access to code, documentation, and detailed instructions. New subdomains and applications. The League plans to expand project lists into agricultural robotics, humanoid robots, and robot manipulators, offering broader areas of exploration and specialization. 8. Steps for beginners. Complete 4 A5 mini-projects. Begin by working on 4 5 mini-projects across various domains like perception, planning, navigation, and control. Mini-projects should last between 2 weeks and 1 month, helping you to define your areas of interest and build a solid foundation in robotics. For example, you might complete a simple robot navigation project using ROS or develop a basic perception system using OpenCV. Undertake 2-3 curiosity-driven projects. Choose projects based on personal curiosity and explore areas of robotics that excite you. Examples could include working with machine learning algorithms to enhance robot behavior or experimenting with robotic arms for industrial applications. Define your niche. Once you've explored various subfields, it's time to define your niche within the robotics space. Leverage Velocitech's resources and tools to narrow your focus on a specific aspect of robotics, so whether it's AI-driven navigation or developing autonomous robots for specific applications like warehouse automation or precision farming. 9. Build a portfolio and prepare for the job market. Build a strong portfolio. Compile all your significant projects and mini-projects into a portfolio that highlights your skills and hands-on experience. The Velocitech Engineering League provides a platform to showcase your work through online portfolios, GitHub, and personal websites. The portfolio should be comprehensive, including major projects in your niche and smaller mini-projects that demonstrate your versatility and foundational knowledge. Prepare for interviews. Include your projects in your CV and motivation letter, emphasizing how your skills align with the requirements of potential employers. Create a presentation to showcase your projects, tailored to each job application. Regularly practice answering theoretical questions in robotics, machine learning, and software engineering. Utilize online resources like top interview questions on platforms like Glassdoor to prepare thoroughly for technical interviews. Find job opportunities. Explore job postings on sites like Roscon, Automatica, and robotics job boards. Investigate roles with leading companies in the field, such as Magazino, Agile Robots, and Neural Robotics, to understand the skills and expertise required for specific positions. Velocitech supports engineers in navigating the job market by providing access to exclusive internship and job placement opportunities through industry partnerships. Learn essential skills. Ensure that your skill set is market-ready by mastering essential tools like Git for version control and showcasing your projects on GitHub. Keep up with industry demand by continually refining skills in C++, Python, ROS, computer vision, and machine learning are all highly valued in the robotics job market. Follow the guide step by step. Stick to a clear progression path that avoids skipping critical skills or tools. The Velocitech Engineering League provides a structured guide to ensure that no critical learning areas are overlooked. By following both practical and theoretical insights, you can excel in robotics software engineering roles, prepared for both technical tasks and project-based collaboration. By following the steps in Velocitech Engineering League, engineers will build the expertise necessary to thrive in the robotics industry, gaining both practical skills and a well-rounded understanding of the field, ensuring success in robotic software engineering and preparing them for career advancement. Capital Investment Presentation, The Racing Edition. Property Address, 930 Velocitech Robotics Court, Madripoor. Home of the Crusader Cyclone Racing Division. Where engines roar, lasers fire, and ROI burns rubber. Slide 1, welcome, racing enthusiasts and capital wizards. Ladies and gentlemen, welcome to the ultimate fusion of precision engineering and financial brilliance. I'm here to turbocharge your portfolio with the opportunity of a lifetime. Today, we'll focus on the KPIs that make this property not just an investment, but a championship-worthy addition to your financial lineup. And yes, I'll keep it fast and furious, just like our Crusader Cyclone Racing Edition. Slide 2, NOI, $750,000. That's right, this property's net operating income isn't just robust to its revving at full throttle. It's like a finely tuned race car, optimized, consistent, and ready to deliver lap after lap of profitability. Slide 3, DSCR, 2.10. Our debt service coverage ratio is a solid 2.10. Translation? This property handles its financial curves like a dreamer, steady, reliable, and with enough breathing room to absorb any bumps in the track. Slide 4, Occupancy Rate, 86%. With an 86% occupancy rate, this property is already on the podium, leaving competitors in the dust. That's the kind of performance you expect from a championer, and it's only getting better. Slide 5, Tenant Credit Quality, BB. Now, I know what you're thinking, BB? Think of it as the scrappy underdog in the race here, dependable, ready to prove itself, and always paying rent on time. Just like the Crusader Cyclone, it's a little rough around the edges, but it delivers. Slide 6, Market Rent versus In-Place Rent. Market rent is $14/SF, while in-place rent is $13/SF. That's like having a turbocharged engine running at half speed. The upside potential here is real. We're talking pole position potential, folks. Slide 7, IRR, 11.2%. With an internal rate of return of 11.2%, this property isn't just profitably, it's the track champion. It delivers returns so consistent, you'll think it's running on autopilot. Slide 8, NPV, $1,800,000. Net present value of $1.8 million. That's like crossing the finish line with a checkered flag in one hand and a champagne bottle in the other. This property pays off now and in the long run. Slide 9, Cash on cash return, 10.5%. A cash on cash return of 10.5% means you're getting more than just your money's worth, or you're getting a front row seat to the winner's circle. Slide 10, Valuation and $PPS. With an asking price of $7.5 million and $50 per square foot, this property is priced to sell faster than a Crusader Cyclone on a drag strip. Did I mention replacement cost is $8 million? You're basically buying a fully loaded race car at used go-kart prices. Slide 11, EAUC, 1000 Power Brokers Score, 4 stars. 1000 engineered operating cycles, EAUC. This property's performance is as reliable as the Crusader Cyclone's dual laser cannons. And with a 4-star Power Brokers Score, you can trust this deal is the real deal. Slide 12, Call to Action. Ladies and gentlemen, the checkered flag is in sight. This property isn't just an investment, it's a legacy. A chance to combine financial dominance with the spirit of competition. So, who's ready to claim their spot on the winner's podium and drive this property into their portfolio? Let's go full throttle invest in Velocitech Robotics Court today. And remember, this isn't just real estate, it's a race to the future.